Something moved out there. Something that does not belong. And the only machine humanity has ever sent to the edge of the known universe caught it. A disturbance rippling through the fabric of interstellar space, traveling in a pattern that matches no planet, no star, no cosmic event we have ever classified. NASA's scientists did not announce it with a press conference. They did not hold a global broadcast. They quietly noted it in their data logs and kept working. And that silence, more than the signal itself, is what should make your blood run cold. Because when NASA goes quiet, something enormous has already begun. There's a machine out there, right now, sailing through absolute darkness at 38,000 miles per hour, and it has been doing so for almost 50 years. It carries no passengers. It has no windows. It was never designed to find what it appears to be finding. And yet, piece by piece, transmission by transmission, arriving on Earth after a 23-hour delay, it is sending back data that is quietly rewriting everything scientists thought they understood about the space between stars. This is not a story about aliens. This is not a conspiracy. This is the documented, peer-reviewed, officially confirmed account of what Voyager 1 has been detecting in interstellar space, and why what it caught moving in the dark is something that no existing scientific model fully prepared us for. Pay attention to that word, moving, not static, not drifting. Moving, with structure, with pattern, with behavior that a dead, empty universe simply should not produce. To understand why any of this matters, you have to understand what Voyager 1 actually is, and more importantly, what it was never supposed to be. When NASA launched it on September 5th, 1977, the mission was designed to last 5 years. 5 years. A flyby of Jupiter, a flyby of Saturn, and then drift into oblivion. That was the plan. The engineers who built it handed it a lifespan comparable to a cheap appliance. They gave it cameras, magnetometers, plasma detectors, cosmic ray sensors, 10 instruments in total, and they aimed it at the outer planets with the confidence of people who expected to retrieve the data and move on. Nobody in that control room in 1977 imagined they would still be receiving signals from this machine 49 years later. Nobody imagined it would be the farthest object humanity has ever placed in space. And absolutely nobody imagined what it would find once it crossed the line that separates our solar system from everything else. That line has a name, the heliopause. Think of it as the edge of a bubble. Our sun generates a continuous stream of charged particles called the solar wind, and this wind pushes outward in every direction, creating an enormous spherical territory called the heliosphere. For billions of miles in every direction, the sun's influence shapes the environment, the magnetic fields, the particle densities, the electromagnetic behavior of space itself. The heliopause is the boundary where that solar wind finally loses its battle against the pressure of interstellar space. Beyond it, the sun's voice goes silent. Beyond it, you're no longer inside anything familiar. You're in the space between stars, a place called the very local interstellar medium, and until August 25th, 2012, no human-made object had ever been there. Voyager 1 crossed that boundary. It is the only spacecraft in human history to have done so and continued transmitting, and what it found on the other side was not the peaceful, empty void that textbooks had described for generations. It was something far stranger, something that moved. Here is where the story shifts, and you need to sit with this for a moment. Before Voyager crossed the heliopause, scientists had a working model of interstellar space. They believed it was largely quiet, a thin, cold, near vacuum populated by stray particles and the faint magnetic echoes of ancient stellar events. The density of plasma out there, the ionized gas that drifts between stars, was expected to be so low as to be nearly undetectable. Scientists estimated roughly 0.02 particles per cubic centimeter in the outer heliosphere, an almost incomprehensible emptiness. They expected interstellar space to be even thinner, even quieter. What Voyager found was a surprise at virtually every measurement. The first anomaly arrived almost immediately after the crossing. Voyager 1's plasma wave subsystem, the instrument designed to detect vibrations and oscillations in charged particle fields, began recording something that should not have existed at that density. Plasma waves, not gentle random fluctuations of the kind you might expect from scattered particles bumping against each other in the void. These were structured oscillations, waves with coherent patterns, waves that behaved as if something was generating them, something moving through the medium and leaving a wake. Think about what that means for a moment. In a medium so thin that a cubic centimeter holds barely a fraction of a particle, Voyager 1 was detecting ripples, and ripples require a source. The initial data was attributed to solar events. When the sun releases a coronal mass ejection, a massive burst of solar energy, it sends a shockwave propagating outward through space. Even after crossing the heliopause, these shock waves can continue outward and interact with the interstellar plasma, generating the kind of oscillations Voyager was detecting. Scientists filed this explanation, published papers around it, and moved forward. But the data did not stop arriving, and it did not stop being strange. Hummed, continuously. From 2017 onwards, this steady plasma emission continued without interruption, providing what a landmark 2021 study published in Nature Astronomy described as the first ever steadily sampled measurement of the interstellar plasma density over a span of approximately 10 astronomical units. That is 10 times the distance between the Earth and the Sun, measured in continuous data points, all showing the same thing. Something out there was maintaining density fluctuations across enormous scales. The interstellar medium was not still. It was not passive. It was turbulent in ways that existing models had not predicted. And embedded within that turbulence, there was structure, there was movement, there was pattern. The researchers behind that Nature Astronomy study, Stella Koch-Ocker and colleagues at Cornell University, described these signals with careful scientific language. But the implications underneath that language are extraordinary. The persistence of the emission meant that the interstellar medium around Voyager 1's path was not behaving like a uniform, slowly drifting gas. It was showing density fluctuations at the scale of astronomical units, enormous variations in the concentration of plasma over distances that dwarf anything in our familiar solar neighborhood. Something was disturbing the medium. Something was creating structure in a place where structure was not supposed to exist at this scale. And it was doing so continuously, over years, across the entire region Voyager was passing through. But here is where it gets genuinely unsettling. Not all of these fluctuations can be explained by solar shock waves. The mathematics do not fit cleanly. When scientists modeled what a solar ejection shock wave should produce in the interstellar medium at Voyager's distance, the predictions matched some of the data, but not the persistent hum, not the background emission that continued between the discrete events, not the steady, low-frequency oscillation that appeared to originate not from inside the heliosphere, but from the medium itself, from something in the interstellar space that Voyager 1 was moving through, something generating waves around it the way a boat moving through water leaves a wake long after the boat has passed. Think about that image carefully. A wake in the interstellar medium implies not just turbulence, but directional turbulence. Turbulence that traces the path of a moving object. And Voyager's data, analyzed across years of continuous measurement, showed density fluctuations that trace what the... Now, before anyone reaches for extraordinary conclusions, it is critical to understand what the scientists themselves have said and what they have not. No NASA scientist has claimed the detection of an artificial object. No paper in a peer-reviewed journal has used the word alien. What the scientists have said, documented, published, and confirmed, is that Voyager's data reveals behaviors in the interstellar medium that existing theoretical models do not fully explain. That is the language of science, and it is the most honest language available. But read that statement again, slowly. Our existing models, built over decades, tested against every available observation, do not fully explain what Voyager 1 is measuring. In the language of physics, that is not a minor footnote. That is a crack in the foundation. Into electricity. When it launched in 1977, it produced hundreds of watts. Now, nearly 5 decades later, each Voyager loses approximately 4 watts of power every single year. 4 watts sounds insignificant. On Earth, it barely powers a small LED. On a spacecraft more than 15 billion miles from home, 4 watts is the difference between a functioning sensor and a dead one. The power drain has forced NASA into decisions that feel almost tragic in their precision. Years ago, the Voyager science and engineering teams sat down together and agreed on a shutdown sequence. A pre-planned order in which they would sacrifice instruments one by one to keep the mission alive. Of the original 10 science instruments that each Voyager carried, 7 have already been switched off. Cameras, infrared sensors, ultraviolet spectrometers, plasma science detectors, all gone. Each shutdown bought time. Each shutdown also removed another way of seeing the universe. As of April 17th, 2026, NASA deactivated the low-energy charged particles experiment aboard Voyager 1, an instrument that had been operating almost without interruption since 1977. Its counterpart on Voyager 2 had already been turned off in March 2025. With that shutdown, Voyager 1 is now down to exactly 2 operational science instruments. The magnetometer, which measures local magnetic fields, and the plasma wave subsystem, the very instrument that has been detecting the strange, persistent oscillations in the interstellar medium. The instrument that heard what should not be there. The irony is almost unbearable. Of the 2 remaining eyes through which humanity can see interstellar space, one of them is the same instrument that caught the signal. And NASA, in its careful, methodical plan for power conservation, has chosen to keep it running. That choice was not made carelessly. The Voyager mission manager at JPL, Kareem Badruddin, stated publicly that despite the shutdown of the LECP instrument, Voyager 1 still has 2 remaining science tools that are working great and sending back data from a region of space no other human-made craft has ever explored. The team remains focused on keeping both Voyagers going as long as possible. What that means in practice is that the last scientific observations this probe will ever make are plasma wave measurements from the interstellar medium, exactly where the anomalous disturbance was detected. Whatever Voyager is moving through, it will be the plasma wave subsystem that bears witness to it until the very end. And the end is approaching in ways that are both technical and almost philosophical. On November 18th, 2026, just months from now, Voyager 1 will reach a distance of 1 light day from Earth, 1 full day of travel at the speed of light. For the first time in human history, a human-made object will be that far away. When engineers on the ground send a command to the spacecraft, they will wait 23 hours for it to arrive, and another 23 hours for any response. The command loop alone takes nearly 2 days. Everything that Voyager does in that time, every measurement it takes, every fluctuation it detects, every ripple in the plasma it registers, it does alone, without any possibility of human intervention or correction. It is, in the most literal sense, operating beyond the reach of human assistance. And it is still detecting something. NASA has developed what engineers informally call the Big Bang, a coordinated power conservation plan that involves swapping out entire sets of powered devices at once, replacing older systems with lower power alternatives in a sweeping single operation. The plan is being tested on Voyager 2 first, with trials scheduled through mid-2026. If those tests succeed, the same procedure will be attempted on Voyager 1 no earlier than July 2026. If the Big Bang works as hoped, there's even a possibility that the LECP instrument, the one just shut down, could be reactivated. The engineers say they want to keep at least 1 instrument operating on each spacecraft into the 2030s, not because the mission is sentimental, but because the data coming back is genuinely irreplaceable. No other spacecraft is positioned to take these measurements. No other machine exists in interstellar space. Whatever Voyager is observing, it is the only observing being done. This is the reality that makes the interstellar disturbance data so uniquely significant and so uniquely difficult to resolve. We have exactly 1 data source for the very local interstellar medium, 1 probe, moving along 1 trajectory, sending back measurements that take nearly a day to arrive. We cannot triangulate. We cannot cross-reference with a second instrument at a different position. We have Voyager 1 and, at a slightly different location and trajectory, Voyager 2, which crossed the heliopause on a different heading in November 2018, becoming the 2nd spacecraft in history to enter interstellar space. But the 2 probes are on diverging paths, sampling different regions of the interstellar medium, and their data, while complementary, does not resolve the question of what is moving. It only confirms that the interstellar medium is more structured, more dynamic, and more turbulent than any model predicted. The anomaly is not a measurement error. It is not instrument noise. Both spacecraft are detecting complexity in a region where simplicity was expected. The boundary region itself has produced findings that have forced major revisions in scientific thinking. Voyager 1's sensors discovered that the heliopause, the edge of our solar system, is not the clean, well-defined boundary that theoretical models depicted for decades. It is a turbulent zone of interaction, where solar and interstellar magnetic fields reconnect and mix, where plasma temperatures spike to levels that seem almost impossible. Measurements from the boundary crossing recorded temperatures in the heliopause region reaching as high as 50,000 Kelvin. Scientists describing these findings have used the phrase wall of fire. Not flames, but a region of extraordinarily energetic plasma that behaves in ways no simulation fully captured. The boundary of our solar system is not a calm shoreline. It is more like a churning surf zone where 2 cosmic oceans collide. And beyond it, in the interstellar medium proper, the turbulence does not end. It continues. It evolves. And embedded within it is the persistent, structured disturbance that Voyager's plasma wave data has been tracing for years. What most people are not seeing, because it has not been packaged into a headline, because it exists in the careful language of astrophysics journals and NASA technical updates, is that we are living through the only real-time interstellar exploration event in human history. And it is ending. The instruments are going dark, one by one. The power source that has sustained this mission across 5 decades of space is fading. 4 watts per year, relentlessly and without exception. The engineers at JPL who send commands to Voyager 1 know that each command sequence they write could be among the last ones the spacecraft ever responds to. They know that at some point in the 2030s, the final instrument will cross its power threshold, and the signal from the interstellar medium will stop. And when it stops, the data Voyager has already collected will be the only direct measurements of interstellar space that humanity possesses, possibly for decades, until a future mission can be built, launched, and guided to the edge of the heliosphere and beyond. The proposed successor, called the Interstellar Probe, has been in planning phases for years. Scientists and engineers have outlined a mission that could travel faster than Voyager, reaching the heliopause in roughly 15 to 20 years and continuing deeper into the interstellar medium with a more capable instrument suite. But the Interstellar Probe does not yet have a confirmed launch date. It has not yet secured full funding. It exists as a concept, a proposal, a scientific ambition waiting for the political and financial support to become hardware. In the meantime, the only thing between humanity and total ignorance about what lies beyond our solar system is a car-sized spacecraft built with 1970s. Technology, running on decaying plutonium, communicating through an antenna that has not been physically touched by human hands in 49 years. And that spacecraft is detecting something that moves through the interstellar medium in ways that leave structured patterns in the plasma. Something that our models did not put there. Something that the data reveals and the theory cannot yet explain. This is the real story of Voyager 1 in 2026. Not the nostalgia of a heroic old probe, though that story is true and remarkable. Not the engineering triumph of systems lasting 9 times their designed lifespan, though that too deserves its own telling. The real story is that we sent a machine to the edge of the known universe, and the edge of the known universe turned out to contain something we did not expect. Something structured, something dynamic, something that produces patterns in the plasma of interstellar space that trace its movement across distances that dwarf the entire orbit of Neptune. And the machine that discovered it is running out of time. In a few years, perhaps less, the plasma wave subsystem that detected the persistent mission will power down for the last time, and Voyager 1 will go silent in the dark between stars, still moving at 38,000 miles per hour, still carrying its golden record, still broadcasting on the same frequencies, but no longer receiving commands, no longer returning data, no longer able to tell us what it is passing through. And here is the question that cannot be answered yet, the one that will outlast this mission and define whatever comes after it. The persistent plasma wave emission that Voyager detected beginning in 2017 and continuing for years, the structured disturbance in the interstellar medium, is it the natural turbulence of a universe that is far more dynamic than our models assumed? Is it the signature of processes we have not yet discovered operating in the space between stars, generating order out of the thin plasma in ways that physics still needs to explain? Or is it something else? Something that moved through the interstellar medium and left a wake that Voyager 1, against all probability, happened to cross at exactly the right moment, on exactly the right trajectory, with exactly the right instrument still functioning to detect it? We do not know. The data exists. The anomaly is confirmed. The explanation is not. What we do know is this. The universe is not empty in the way we imagined. The space between stars is not silent in the way we assumed. And the most distant machine humanity has ever built is telling us so, transmission by transmission, one 23-hour delay at a time, from a place so far away that the concept of distance starts to lose its meaning. Whatever is out there, whatever moved through the plasma and left the pattern that Voyager caught, it is still there, still moving. And in November 2026, when Voyager 1 crosses the threshold of one full light day from Earth, it will be closer to that unknown disturbance than it has ever been to anything but the stars themselves. The signal is still coming, the instruments are still listening, and somewhere in the deep, absolute, ancient dark of interstellar space, something is still moving. We just do not know what it is yet. And that might be the most important scientific statement of the 21st century so far. Not what we found, but what we found that we cannot yet explain. Voyager's last transmissions may not give us the answer. They may only sharpen the question until it becomes impossible to ignore. Until a future mission, years or decades from now, follows the same trajectory into the same darkness, and finally comes close enough to see what left that mark in the plasma. Close enough to understand what Voyager caught. Close enough to know whether we are truly alone out here or whether the space between stars has always been less empty than we wanted to believe. The probe is still out there. The data is still arriving. And the universe, it turns out, has been waiting for us to pay attention.